Welcome to Cheenta School of Statistics and Data Science. Today we are going to solve question number 57 of GATE 2022 statistics paper. The problem says that in a laboratory experiment, the behavior of cats are studied for a particular food preference between two foods A and B. For an experiment, 70% of the cats that had food A will prefer food A, and 50% of the cats that had food B will prefer food A. So the experiment is repeated under identical conditions. If 40% of the cats had food A in the first experiment, then the percentage of cats those will prefer food A in the third experiment. So basically, we have to find the probability of cats those will prefer food A in the third experiment, given they had food A in the first experiment. Okay, so we can formulate the above problem as a Markov chain. So let us define a random variable xn, which is denoted by the preference of food of cats at the nth experiment. Okay, so what Markov chain actually tells us, that is, if a stochastic process xn, where n is 0, 1, 2 up to infinity, this is a stochastic process with countable state space S. It will be a Markov chain, that is discrete times Markov chain. We say DTMC if the following property holds, that is probability of xn plus 1 equal to j, given xn equal to I, xn minus 1 equal to say in minus 1, and up to x naught equal to I naught. So this probability reduces to probability of xn plus 1 equal to j, given probability of xn equal to I. That is, the future event xn plus 1 depends only on the present and not further past. That is, given the nth event, that it will only affect the n plus 1th event and not n plus 2, n plus 3 up to this. Okay, so this is basically the essence of Markov chain. This will true for all n, and for all I, j, in minus 1 up to I naught belong to the state space S, we say it. Okay, so this is basically a brief history of brief idea about the Markov chain. So now say 1 we consider for food A and 2 is considered for food B. Okay, so the transition matrix is given by 0 0.7, 0 0.3, 0 0.5, 0 0.5. How to calculate the transition matrix? Let us see. So transition matrix is basically what I have told just now. X plus 1 equal to j, given xn equal to I. This is basically denoted by Pij, which is the ijth element of the transition matrix. Okay, so here ij will be I equal to 1, 2 and j equal to 1, 2. So we have basically 1, 2, 1, 2 for calculating the transition matrix. So let's say this is the x naught, or say xn, whatever you prefer. This is x1, or let's say xn plus 1. Okay, so we have to find the probability of x1 equal to 1 given x naught equal to 1, probability of x1 equal to 1 given x naught equal to 2, and probability of x1 equal to 2 given x naught equal to 1, and lastly probability of x1 equal to 2 given x naught equal to 2. We have to find these four probabilities. One is for here, this, one is for this, one is for this, and one is for this. Okay, so let us first find probability of x1 given 1, x1 equal to 1 given x not equal to 1. Okay, so how to find this? We have probability x1 equal to 1 given x not equal to 1 basically means x1 is the preference of food of cats at the first experiment, and x naught is initially what was cat have. So we have the behavior of cats are studied and particular food preference between two foods. So the for an experiment, 70% of the cat that had food A will prefer food B. So given 1, they will also given 1, they will also prefer 1 is basically 70%, 0.7. So that is how we calculate probability of x1 equal to 1 given x not equal to 1. Okay, Now we have to find product of x1 equal to 2 given x not equal to 1. So what does that mean? So the cats will prefer food B given they had food A in the first initially. Okay. So what is the probability? So this is basically 1 minus 0 0.7, 0 0.3. And secondly, we have x1 equal to 1 given x2 equal to, x not equal to 2. This is basically the cat will prefer food A given they have food B initially. So this is basically the probability given here. So the cats that have food B will prefer food A. Given food B will prefer food A. That is given x not equal to 2. They will prefer food x1 equal to 1 is 0.5. So this is how we calculate 0.5 here. And the remaining will be root of x1 equal to 2 given x2 x not equal to 2. This will also 0.5. So that is how we calculate the transition matrix P. Okay. So here this is the transition matrix. We also have the marginal distribution given, that is 40% of the cats had food A in the first experiment. So probability of x not equal to 1 is 0.4 basically, what we have written here. So we have started x1 equal to 1, that is no matter x not x1, x1, x2 all are same as because it only depends on the previous one. And time homogeneous also. Time homogeneous means it does not depend on n. That is probability of x n plus 1 given j, x n plus 1 equal to j given x n equal to I is a function of n. Okay, this is called time homogeneous. Okay, so now we have to find the product of x equal to 1 because the problem says that we have to find the percentage of cats those will prefer food in the third experiment, that is x3. Nth experiment is xn, so third experiment is x3. So probability of x equal to 1. To find it, we have to consider the dependencies as well. So first dependency comes on x equal to 1, x2 equal to j, and x1 equal to I. So we have to sum over all I and j, all possible i's and j's. Okay. So this becomes x3 equal to 1 given x2 equal to j and x1 equal to I into x1 equal to I. This is simply the conditional probability theorem. That is x1, say by event we can say A intersection B intersection C. Basically probability of A given B intersection C into probability of B intersection C. Okay. Okay. This is the conditional probability theorem. Okay. So we apply it here. That is sum over probability of x3 equal to 1 given x2 equal to j, x1 equal to I into probability of x1 equal to I into probability of x2 equal to j into intersection. So what we have written earlier. Okay. So this will reduces to this probability by Markov property. This is Markov property. Because 3 will only depend on 2, not 1. So it reduces the probability by this. And intersection always also can be broken as x2 equal to j given x1 equal to I into x1 equal to I. So this will also, by Markov chain, we can find this from the transition probability matrix, and this is given. So we multiply this for all possible i's and j's. By multiplying, we get 0.7 into 0.7. That is x3 equal to 1 given x2 equal to 1 and x2 equal to 2 separately. Also for j equal to 1 and 2, we have to consider I equal to 1 and 2. So there are 4 possible choices. So these 4 probabilities we add. You can check whether the calculations are correct or not. You have to find yourself. This is try yourself. Okay. So this basically 0.7 to 0.7 to 0.4. That's the calculation you check, and this simply becomes 0.616. So we have the percentage of cash those will prefer food A in third experiment is 61.6%. So the motive of the problem is basically to apply the Markov property that we have learned till now. So the Markov property means we have said that x in the future event depends only on the immediate past and not the further past. So this basically reduces to the probability of xn plus 1 given j into xn equal to I. And this is the Markov property we have, and this is also time homogeneous if this probability does not depend on n. Okay. So thus we calculate the probability as 61.6%. So that is all for today. Thank you for watching. I will see you in the next video. Till then, stay tuned and stay blessed.